Light is a wave. We know that, but how exactly? That's what I'm going to show in this video. Before we answer this question, how do we even go about determining whether something is a wave or not? We can see waves on water, but we can't exactly see light waving up and down while it's traveling. In fact, we can't even see light while it's traveling, so how are we going to determine whether light is a wave or not? It sounds impossible. It turns out that waves have some unique characteristics. Waves can interfere with each other. This means when two waves overlap in space, the amplitudes of the waves are added together. When two peaks of a wave overlap, they reinforce each other, resulting in a larger amplitude along the overlapping region. This is called constructive interference. On the other hand, when the peak of one wave overlaps with the trough of another wave, the two cancel each other out, resulting in an amplitude of zero. This is called destructive interference. We've actually already seen an example of interference in the previous video on lasers. Waves can also diffract around objects. What this means is that if an obstacle is placed in the path of a wave, the wave will bend around the obstacle. This causes the wave to change its direction of propagation and spread out in all directions. Here we have an example of diffraction around an impenetrable barrier. When the wave reaches the barrier, it is reflected and starts spreading out in all directions. This causes it to travel around the barrier and also creates interference patterns with the rest of the wave that was not diffracted. Diffraction also happens when the wave passes through a narrow opening in a barrier. In this example, the wave is passing through an opening that is wider than the wavelength. This results in a diffraction pattern consisting of three separate bands. The band in the middle is the widest and has the highest amplitude, while the two bands on either side are narrower and with a lower amplitude. When the opening is made as wide as the wavelength, the wave spreads out evenly in all directions, as though it is originating from a single point. Now let's add a second opening at a distance of 2 wavelengths from the first opening. We start to see constructive and destructive interference occurring, which results in alternating bright and dark regions. This distinctive pattern is called the double slit diffraction pattern and is a telltale sign of a wave. We can thus determine whether light is a wave by shining a beam of light on two slits that are approximately 2 wavelengths apart. If we observe the same diffraction pattern, then that means light is a wave. If light is not a wave, we will only see 2 bright stripes. This experiment only works if the light is coherent and the slits are roughly 1 wavelength wide. If the light is incoherent, we don't see a diffraction pattern. Similarly, if the slits are significantly wider than the wavelength, we don't see the double slit diffraction pattern. So, let's try it with real light this time. We'll need a source of coherent light, such as a laser, and a piece of cardboard in which we are going to cut 2 narrow slits that are 1 wavelength wide and roughly 2 wavelengths apart from each other. Given that red light has a wavelength between 620 and 740 nanometers, the slits have to be extremely narrow, around 1/100th of a millimeter wide, in order for a diffraction pattern to appear. Now let's shine the laser on the slits and see what happens. We see a pattern of alternating bright and dark bands, just like the double slit diffraction pattern that we saw earlier in the wave simulation. This proves that light is a wave, or at least exhibits the behavior of a wave. If light didn't have a wave nature, we would only have seen 2 narrow stripes close together. This experiment was actually originally performed by Thomas Young back in 1801 and was the first proof that light has a wave nature. This is an incredible accomplishment, considering lasers and electric light bulbs hadn't been invented yet. To end off, you now know that light is a wave and how to prove it. As always, thank you for watching and stay tuned to this channel for more interesting videos.